A. Calculate the self-inductance of a 50.0 centimeter long, 10 centimeter diameter solenoid having 1000 loops. How much energy is stored in this inductor when 20.0 amp of current flows through it? How fast can it be turned off if the induced EMF cannot exceed 3.00 volt? So what are we given here? We are given the length of the solenoid, which is 50 centimeters, and converting it to meters, that will be 0.5 meter. And the diameter of the loop is 10.0 centimeter, and that implies the radius is half of the diameter, 0.05 meters. And the number of turns of the solenoid is 1000 turns. So what is A asking for? A is asking for inductance, L. And we know that the inductance of a solenoid is given by mu naught n squared A over L, where mu naught is permeability of free space, and that is actually equal to 4 pi times 10 to the minus 7 Tesla meter per amp. That's a constant. It's a table value, where n is the number of loops, and area is area of the loop. And area of the loop, we're assuming it to be circular, is solenoid. That's going to be pi r squared. So now we can just plug in the numbers and calculate for L. L will be equal to 4 pi times 10 to the minus 7 Tesla meter per amp multiplied by the loop squared, which is the number of loops squared, which is 1000 squared, times the area of the loop, which is pi r squared, and that's pi times 0.0500 meter squared, divided by the length of the solenoid, and that's 0.5 meters. And that yields 0.0197 Henry, and that's equal to 19.7 millihenry. Now B, how much energy is stored in this inductor when 20.0 amp of current? So we are given current, and that's equal to 20.0 amp. And what we are asked to find is what the energy is on the solenoid. And we know that energy of a solenoid is equal to 1 over 2 times the inductance multiplied by the current squared. So just plug in the numbers. We have already calculated the inductance in A, and current is given, therefore 1 over 2 times 0.0197 Henry multiplied by 20.0 amp squared. And that yields 3.94 joule. So the energy stored when the current is 20.0 amp is equal to 3.94 joule. And C is asking for how fast, so lapse of time or time is required given the induced voltage. And we know the induced voltage is 3.00 volt, but that's going to be negative because induced voltage is always opposing the current. So minus 3.00 volt. We are asked to find the time, and we know that the induced voltage is given by negative of the inductance multiplied by the rate of change of current. So we are asked to find for delta t, so we multiply both sides by delta t, divide both sides by the induced voltage, and that yields delta t equals negative L over times delta I over E. Just plug in the numbers. Negative 0.0197 Henry for the inductance, 20.0 amp current, divided by negative 3.00 volt, which is the induced voltage, and that yields 0.131 seconds. Thank you for watching.